Welcome back everyone. In the previous playlist, we learned how to securely provide AWS for Kubernetes workloads using OpenID Connect, IAM roles for the service, also known as the IRSA. In this playlist, we are going to explore the newer and simplified approach introduced by AWS called EKS Pod Identity. Instead of configuring OpenID Connect providers and creating trust policies for every service account, we will see how EKS Pod Identity makes AWS authentication much easier to manage. We will create an EKS cluster, configure EKS pod identity for the required add-ons, and the AWS load balancer controller, deploy our application, we expose it using the Ingress resource with an application load balancer. If you are wondering when to use IRSA and when to choose EKS pod identity, this playlist is for you. Without wasting any time, let's get started. Let me start creating the cluster using the custom configuration and naming my cluster as learn with Kabil-EKS. And the cluster IAM role will be EKS cluster role. Let the other settings be default. Click on next. I'm choose PC. Click on next. And I'm not selecting any of the observability metrics as in playlist 1. We are configuring the Prometheus and Grafana monitoring stack through the Helm chart. So we are not using any of these parameters. So simply click on next. Under add-on section, we are going to install multiple add-ons uh, at a single go, not like the playlist one by one. We are not going to add proxy core DNS, EPC setup, EBS CSA driver, and yeah, this is the major add-on that we need to enable for this playlist to setup, okay, which is EKS Pod Identity Agent and the add-ons like external metric servers. For next, and here itself we need to choose the IAM roles and all for each add-ons. Like this will be managed by the EKS pod identity and itself. Okay. Create a new role. It will be auto-populated with EKS pod identity by default only. So just leave it after verify the cluster role name. I mean the role name for this add-on and verify the policies are attached to it. Click on create role, and after that for the EBS CSA driver add-on, click on create new role. It will also get auto populated and verify that this role is auto populated with the policy as well. Create role. Okay, after create of these roles, go next and validate the its configurations we sent for this cluster setup and create the cluster. Okay, for the add-on version means variety of the add-ons. EKS pod identities will be good with the required service. For these are configured with EKS pod identity setup, not with OpenID Connect ARSA. The service account or EBS is control SA. AWS I. Click on create. It will take approximately 15 minutes for the cluster config or the cluster creation. If you see now, it almost took 8 minutes to create the cluster. Once the cluster is in active state, we will start creating the worker node. Go to the compute section, add node groups. I'm naming the node group as workers. Create a new role. You will get auto-populated and verify the policies are attached to it. Create the role, click on next, and let it be default. Click on next, and I'm allowing only the public subnet for the endpoints to be accessible via for the remote access to the nodes. I'm enabling it for my purpose. Add the security group as well. Click on create. It will take some time for creating the worker nodes. In the meantime, let me update my kubeconfig file like we did earlier in our playlist one setup. Let me switch back to my terminal. Get context. Yes, you were using my previous cluster, because if you do kubectl get pods, you will get an error unable to connect to the server. Why? Because there is no cluster the existing identity in my kubeconfig. So I need to update my kubeconfig to the present cluster one. Okay, let me do that. AWS EKS update kubeconfig region. Okay, it's AWS, not AWK. Okay, it's updated. Let me verify. Okay, this is my current clusters. Okay, let me create the namespace now itself. Create portfolio as well as the monitoring namespace as well. check whether the nodes are active or not. Get no. Okay, nodes are created and it's in ready state. Yeah. For this EKS Pod Identity setup, we will start configuring the AWS load balancer controller. Similar to our existing playlist one, we need to create the roles and make sure we need to assign that roles with EKS Pod Identity to our cluster. Let me show you how to do that now. Let me switch back to the AWS console. Let me open the IAM. Under IAM section, click on roles, create role. Under the trusted entity type, let it be chosen as AWS service. Under AWS service, select EKS. Under EKS, we need to choose the use cases EKS pod identity. Yeah. Under the use case, we need to choose EKS pod identity. Now click on next. Uh, Use any existing policies. If you have that previous policy, you can select it. Otherwise, you can create inline policy, which you need to copy paste the entire policy, which I have with this opened. Here, let me copy this entire JSON file and paste it over here. Click on next and provide the role name as KS load controller. Click on create role. Okay. After the role gets created, we need to attach this role. I mean, we need to associate these roles with our cluster. Let me switch back to the cluster. Okay. Under cluster, we need to go to access section. Under access section, we need to go to pod identity association. Under the pod identity association, we need to create and the IAM role. Like for pod identity configuration, we need to choose the existing role which we created now, which is case load balancer controller role. And target IAM role, which is optional. We can ignore this. Kubernetes namespace will be kube-system and Kubernetes service account will be load balancer controller. Is W just copy this service account name so that we can attach this service account. I mean, we need to create this service account locally to the cluster as well. Like click it on create. Pod identity association successfully created. Hit refresh. Now switch back to the terminal and create the service account locally as well. Okay, the service account name is AWS Load Balance Controller. I have created it with SCA, right? Let me modify my service account file and rename the what we created. This, save this, apply this manifest, apply service. Okay, the service account is created now. After creating the service account, we will deploy the AWS load balancer controller. Okay. Let me install the load balancer controller now. I have mapped my service account name as -sa with which I created for this EKS Pod Identity setup. So with this service account name, I'm installing the load balancer controller through the Helm charts. If you see now, my AWS load balancer controller is deployed successfully. Let's verify the cluster for the pods which are created. You see, get pods name. This is yeah. If you see now, load balancer controller, everything is in running status. CSI control for DNS, pieces setup, everything is in running active status. So after creating of this, we will deploy the infra resources like storage class and other load balancer, those kind of configuration we will deploy and all. Okay. I, let me deploy the storage class, which is of retain claim policy, the EBS driver add-on. Okay. By default, we have. If you remember, in my previous playlist, I have configured the custom resource definition for the gateway and all. But for Ingress, by default, it will be available in our cluster. We are not going to install any here disk now. So just verify any Ingress classes is available or not. Get yes. Okay, by default, ALB Ingress class is available. So we need to only deploy the uh, Ingress. Okay, for the portfolio application as well as the monitoring stack application. All are host based ingress routing. Okay. Let me deploy the ingress as well. kubectl play. All are host based only. Okay. For monitoring as well, I'm going to deploy them. I'm going to apply them. Okay. Just check for various resources. Under portfolio and monitoring namespaces, it will be visible. Okay, if you see now, these all are these are all the available route based, I mean host based setup for the host name that we need to access our application, and the address section is populated as well, which means load balancer is created successfully. Okay. In this address section also it will get auto populated after some time. Let's verify that as well. Okay. Currently it is visible only for learn with kabil.in. For grafana.learn with kabil.in and Prometheus, it will be the same because it will be of one ALB setup only. We can reach out to multiple backend applications with host-based routing with different port numbers and all. So that's one of the benefit for using this Ingress as well as gateway routes and all. Okay. Let me validate this again. Not populated yet. Let's okay. Let me deploy the application in the meantime. Okay. For that, let's verify everything I have deployed or not. V3 storage class portfolio. Yeah. Think this is path based on. This is path based. So I'm not going to deploy any means. I'm not going to apply this manifest file for path based routing. Only going with host based routing. So let me deploy the application now. Okay. Going to deploy through Helm charts. All portfolio. Okay. Before applying, before deploying the applications, we need to label our nodes. Okay. kubectl get nodes. kubectl label application equal to the same label names only I'm applying. Role equal to monitoring, and for the other node the role will be of database. Once the nodes are labeled, let me deploy my application. This portfolio. If you see now, my application got deployed. Let me deploy my monitoring stack application as well. Let me install monitoring. Use this is the customized monitoring values YAML file. So we need to deploy for our monitoring stack dots as well, which are to the playlist one. Hyphen is monitoring. Repository is hyphen. In the meantime, let's check for the ingress resources got populated with the address section or not. Ingress. Yeah, if you see now, this is also populated with the same address section as I informed. Okay, let me copy the admin password for the Grafana. Let's validate via the curl command first. Curl hyphen there. Dot the URL will be this of permanently. Okay, it will be with HTTPS. Okay, I've configured the SSL certificate, so we check with HTTPS. Okay, SSL certificate unable to get local issues. Okay, let me check. Okay, let me check by modifying the DNS entries as well. Okay, let me add the record section in my console as well. Okay, let me back my browser window. Let me add the alias record. It will take some time to get resolved to the uh, recent mapping of these records, DNS entries and all. Let's wait for some time. With this command, I can ignore the certificate verification. and it is working fine. This I can able to reach my application .com. Okay, let me check in the browser as well. Let Yeah, it's visible now. Yeah, similar to that we can configure our Grafana application like what we did done for our playlist one setup. We can configure the DB connections and make sure how many users visited the application, like how many submitted the details that we can gather through the API setup which I have done. Comparatively to the playlist 2 with EKS Pod Identity is very easy to configure, but to the OpenID Connect and IRSA setup. Yeah, thank you for watching.